Okay, hi, so welcome to this, which is going to be the first video in the Unit 1 Physics series for AQA Science. So this is included in Core Science, Double Science, and of course the individual Physics module as well. Now, in this video, we're going to speak a little bit about infrared radiation. Now, we've probably heard about infrared before. It's something which you can find in many things at home. For example, in mobile phones, a lot of them have infrared sensors. Your TV remote might be controlled via infrared. Now, the first thing we know, or we need to know about infrared, is that every object, and that includes you and me, every object emits, and emits is just the fancy word for saying gives out, so emits infrared radiation. I'm going to shorten it to IR. Emits infrared, but they don't all emit the same amount. And so hotter objects emit more infrared. So as something gets hotter, it starts to emit more infrared radiation. If something cools down, it will emit less infrared radiation. Now, the reason it's called infrared is because in the electromagnetic spectrum, it's just next to red light, which of course we can see. Now, we're going to go into this in a lot more detail later on, so don't worry yourself too much about it at the moment. But this here is known as a prism. So this is a prism. Okay, and what it does is when you shoot white light at it, so this is white light, and white light basically contains all the colours, but it'll also contain other types of radiation, including infrared. So white light is shot at the prism like so. The white light then splits into its component parts. So you've got all the different colours that we can see here. So red over here, down yellow, green, blue, violet, etc. down the bottom. Now, it's also splitting into infrared and into ultraviolet, but of course the reason we don't know they're there from looking at this diagram is because we can't see infrared and we can't see ultraviolet. Infrared just means it is this side of the red, so it's next to red, and so we'll also have radiation here. I've drawn it in red, of course, but this is infrared. Down here, ultraviolet, so it's next to the violet, we will have ultraviolet like so, and so that is UV. And the reason we can't see them, of course, is that our eyes are only capable of detecting light which is in the visible spectrum. But infrared is very similar to visible light, but it is found sort of next to the red region. And so, bearing in mind that things which are hot will give off infrared, if we placed a thermometer here, so this is an awful drawn thermometer. That's a thermometer. We would detect temperature increase as a result of this infrared. So the temperature would go up as a result of the infrared being present on this side of the red light. Now, collectively, infrared, visible light, so this is vis or visible light, UV, along with a fair few others, which include microwaves. You will have, of course, heard of microwaves, radio waves, X-rays, and things known as gamma rays. More about this will come later, of course. These are all collectively known as the electromagnetic spectrum. Well, they're all part of the electromagnetic spectrum. And that just describes different forms of radiation, so infrared, visible light, X-rays, etc. But they all have some very common properties to each other. And like I say, we'll go on to that more later, but we just need to know that infrared is, of course, part of this electromagnetic spectrum. So is visible light, so are all the rest of these, and infrared is no different. Okay, now where does all this electromagnetic radiation come from? Well, all of the electromagnetic spectrum, so electromagnetic, I'm just going to say EM, all comes from the sun. From the sun. So the sun can emit every type of electromagnetic radiation. We're all emitting infrared radiation because we all have a certain temperature, but we're not all emitting X-rays. But the sun will emit all of it. And so why aren't we being damaged all the time by these X-rays? Well, the Earth's atmosphere will actually block out most of the harmful radiation. Earth's atmosphere will block out harmful radiation. Okay. It will not block the IR, infrared. And this is actually how we can feel the heat from the sun. Because obviously the sun is thousands of degrees. If we could feel thousands of degrees, then of course we would be dead. And so luckily that's not what happens. We feel the heat because of the infrared radiation given off by the sun. And for us, it's at an appropriate level. Now we can take advantage of this infrared radiation and use it in order to provide us with energy. You've obviously heard of solar power, and solar power is taking the heat from the sun and turning it into useful energy. Now we also have things which are known as solar furnaces. So this here is a diagram of a solar furnace. And what these do, very cleverly, they focus all the infrared radiation from the sun into one point. So this radiation is travelling in like so. Let's do that in red. So the radiation continues travelling in and blah blah blah, travels in, and all of it is reflected back into the same place. So this here is where it's all reflected. So I'm going to draw a big blob here, and that's where it's all being reflected to, and that will allow us to achieve temperatures in the thousands of degrees. So approximately 4,500 degrees Celsius, and that's just from using the infrared radiation from the sun. Okay, now lastly, something which I'm sure you've all heard of is the greenhouse effect. The greenhouse effect. Now, this is as a result of infrared radiation. What's happening here is infrared radiation is coming in from the sun, and this is short wavelength infrared, so IR. Okay, this is allowed through the Earth's atmosphere. This line here represents the atmosphere, and of course down here we just have the Earth's surface. So this blue line is the atmosphere. So short wavelength IR comes in, and what happens is that heats up the Earth, and it heats up the atmosphere and things in the Earth as well. Now, what happens then, of course, is remember we said that anything with a temperature is going to release infrared. Now, if you have a massive amount of energy, you are going to release short wavelength IR, so that's why it's coming from the sun. At the Earth, we aren't as hot as the sun, we're not anywhere near as hot as the sun, and so most are going to be released, most IR is going to be released as long wavelength IR, because it doesn't have as much energy as the sun. Now, long wavelength IR is blocked by the Earth's atmosphere. So the Earth's atmosphere says, no, you're not allowed, and so it's just reflected back towards the Earth again, and if this continues, then this is known as the greenhouse effect, because obviously if we have more infrared coming in from the sun, but not as much of it can leave, we are going to get a build-up of infrared, which is going to heat up the planet. Now, of course, we have what are known as greenhouse gases in the atmosphere, which are contributing to not allowing this infrared to leave. Some gases don't block this long wavelength IR, and then it can leave. Some gases will block the long wavelength infrared, and that means that it can't leave. Okay, and so that is why we realize that the greenhouse effect is a big problem, and it is actually as a result of infrared radiation. Okay, so I'm going to stop there. I hope that was a useful introduction into what infrared is. We'll go on and talk about the electromagnetic spectrum more in later videos. But for now, if you have any questions, please feel free to send me an email by using the link below, or write a comment and I'll be sure to get back to you. And I look forward to seeing you in the next video.